A very good morning to all the participants. I welcome you all to the second day of the 1 week online FDP on harnessing virtual labs for effective student engagement. We had a great start yesterday with Professor K.V. Gangadharan sir giving us an initiative on the virtual labs project. And we also have heard from Mr. Mervyn Thomas, Dr. Mervyn Thomas sir. He is on the fundamentals of robotics and also how we can use the virtual labs platform to teach the students on robotics. So we are glad to have them yesterday. And today we are very grateful to have Ms. Shrestha from Virtual Labs team. And we also have Mrs. Akshaya Acharya from NITK Virtual Labs Development and Outreach team at Center for Systems Design, NITK Surathkal. They will be handling today's sessions and they'll be sharing the sessions today. So without wasting much time, I would like to give this time to Shrestha ma'am. Over to you, ma'am.
Thank you, sir. Hope my voice is clear and audible.
Yes, sir. Yes, ma'am. Yes.
Thank you. So very good morning to all present here. So myself, Shrestha, working as part of Virtual Labs Outreach and Development team here at NITK Surathkal. So I, on behalf of Virtual Labs team at NITK Surathkal, welcome you all for today's session on Virtual Labs. That's domain-specific session on Virtual Labs, especially in IT domains. Okay, so I hope you all were there for yesterday's session as well. Okay, so let me share my screen. So what we'll do is, we'll quickly have a discussion or a summary on what we discussed about Virtual Labs yesterday, the important features, types, and also some additional things. And then we'll have domain-specific example demonstrations of experiments from different labs. Okay, so with that, let me stop my video and share my screen. Yes, hope my screen is also visible.
Yes, ma'am.
Yeah, it's visible.
Yeah, thank you. Okay, so we'll quickly go through these slides on Virtual Labs first. So what exactly it is? These are computer-based labs, and basic structure here as well is similar to a regular curriculum, that is experiment is the basic module. Okay, so these are MOE Government of India initiative under National Mission on Education through ICT. So when I say national mission, it is an umbrella mission which takes care of various ICT initiatives. We might know many of this: Swayam, Swayam Prabha, Virtual Labs, Yantra, and so on. So Virtual Lab is also one of the ICT initiatives which was started long back, that is around in 2010, and it is still an ongoing project from the ministry. Okay, so we can consider Virtual Lab as an extended version of NPTEL. Okay, so what is the basic idea over here? Basic idea is to provide remote access to n number of labs and experiments for n number of users through internet. So then what are the features? Virtual labs are 3P lab. Features we already discussed yesterday. KVG sir and Marvin sir both, they were stressing on a few of the important points. So virtual labs are anytime, anywhere lab. That is, user need not come to physical lab to work on these. He can access these labs at any time, early in the morning, late at night, whichever time he is convenient to it. And also, there is no control speed, that is independent of speed. He can perform these experiments at his own, he can take his own required amount of time to understand and complete the experiment, right? So these are important features, and also virtual labs are free to use. Then we require, what is the requirement? We basically require computing device with internet connection. And when I say computing device, it could be desktop, laptop, or even using our mobile phones, we can work on these labs. And one more important feature is, as we saw with an example yesterday, virtual labs, it has a structure very similar to our lab manual. So what all we ask students to write in the record book, similar to that, we have contents for every experiment here as well, starting with aim of the experiment, followed by theory, procedure, some set of questions to test one's understanding levels, some reference links if one wants to know more about the concept, right? So, and also procedure to perform the experiment here in this virtual labs platform and the simulation. So these are some of the major features. Then moving with the types, virtual labs are classified into three different types based on scalability and closer to reality. So simulation based, measurement based, and remote triggered are the three types. So quickly knowing the difference between the three, simulation based virtual labs are mainly based on mathematical equations. That is, using formulas, we develop simulation. Whereas in second type, measurement based, it is mainly dependent on data set. Okay, so here somebody say lab developer will perform the actual experiment, and whatever data he gets would be stored in the server. And whenever user performs the experiment through virtual labs platform, he would be getting that stored data. And in third type, that is remote triggered type, user himself can trigger the actual experiment, but remotely. Say experiment is at NITK Surathkal, you from anywhere across the world can trigger that experiment. Then he can see the experimental live feed or camera and can get real-time data as output in case of RT labs or remote triggered type. But since real equipments are involved, we find very less number of experiments in RT labs, whereas we find 1000 plus experiments available for simulation and measurement type of virtual labs. Okay, so these are the three types and the differences. Difference between physical and virtual labs, similar to the features. So you can see the factors. Since no equipments are involved for virtual lab, cost involved is almost nil. Availability, as I told earlier, these are available all the time. Here, experimentations, one need not worry about the damage of equipments or boundary limitations. So it provides wider and safer options to do innovative experimentations. Only thing is, it is not an alternative to physical lab, complete alternative to physical lab. No, it is basically a tool to experience the concept. And when we say concept, it could be theoretical concept or experimental concept. Okay, so it could be theoretical concept or practical ones, what students or we do in our physical lab. Okay, so these were some of the reasons why government started the project. Okay, so to overcome physical distance limit, to share costly equipments among the institutions, to provide quality labs. So these were some of the major reasons why government started the project. And virtual labs are available in different domains, 7 engineering and 2 basic science domains. And who developed these labs? So we have 11 participating institutes, 6 old IITs, Triple IT Hyderabad, 2 private universities, NITK Surathkal and COE. Okay, so we develop labs in different domains, so mainly involved in the development and outreach, spreading the awareness between individuals. Okay, and at NITK, Center for System Design, a transdisciplinary R&D center, takes care of this project. So it is headed by Professor K.V. Gangadharan sir, whom you heard yesterday in yesterday's session. He is heading the center. And many of the projects are also coordinated by Dr. Prithviraj Umesh, who is an associate professor in the Department of Water Resources and Ocean Engineering. And virtual labs at NITK Surathkal works with the name SOLVE, that is Student Online Laboratory through virtual experimentations, SOLVE, and we have currently 400 or 450 plus nodal centers onboarded for this virtual labs project through NITK Surathkal. And as communicated yesterday, for any institute to be a nodal center for this virtual labs project, you are required to fill that expression of interest form. That has to be filled. Head of the institute has to sign that, and signed copy, the scanned version has to be mailed to us. Okay, then institute will be onboarded as virtual labs for as nodal center for virtual labs, and nodal center will have specialized advantages as communicated by Gangadharan sir and Marvin sir yesterday. Okay, so that is regarding nodal centers, and whatever activities we do here will be updating in our social media handles. So in Facebook, Instagram, and YouTube, we have channels. Okay, so both two channels, csd.nitk or csd_nitk in Instagram, and sol.nitk is one more ID. So both are, one is our center name and sol is the name that virtual lab works here. Okay. So, and Lagupata is short video tutorial series available to guide user with the usage of virtual labs. So this is available in our YouTube channel. You can explore our YouTube channel videos, playlists, different playlists, and get familiarized with what are the different activities we do here as a center. Okay, so overview on different projects are available through videos in our YouTube channel or other social media handles, which you can explore, and you can ask your students as well to follow and explore in their free time. So this was an overview of what exactly is virtual lab. So this is the summary of social media handles. Okay, so you can just note down and look into that in free time. So this is about what it is, or summary of what we discussed yesterday. Now, as you saw yesterday, virtual lab is not a software. I'll just stop sharing my screen and reshare. Virtual lab is basically a website. So this is the website of virtual labs. In Google, if you just search virtual labs, the first link will take you to the website. Our link is vlab.co.in, vlab.co.in. Okay, so these are the broad areas and participating institutes. So you can go through any of the domain to get list of labs, and inside each lab we'll have list of experiments. So that's what we explored today. Okay, so one thing we need to remember here, when we are looking for a concept of our interest, we need to look into relative domain labs and experiments as well. Say, for example, if you are from computer science or information science domain or any allied branches, we need to look into labs under computer science, electronics and communications, electrical, also physical sciences domain. So all these will have at least few concepts that are relevant to our domain. Okay, so with this, let me stop sharing my screen and stop presentation from my end, and I'll hand over the presentation to Akshaya, who is also from Virtual Labs Development and Outreach Team at NITK Surathkal. So she'll be taking you with domain-specific demonstrations in IT domain. So thank you. Over to you, Akshaya.
Thank you, Shrishta. I hope my voice is audible.
Yes, Akshaya.
Yeah, thank you. Good morning, everyone. I'm from Virtual Lab Development and Outreach Team at Center for System Design and ITK Surathkal. So today I'll be demonstrating the resources available in Virtual Lab portal for the computer science and engineering and its allied branches. Let me share my screen. Hope my screen is visible.
Yes, Akshaya, maybe you can be slightly louder if possible.
Yeah, sure. Is it okay now?
Yes.
Yeah, thank you. The link to the website is shared in the chat box. So a brief introduction to the website has been given by Shrestha already. So this virtual lab portal is mainly useful for the learning purpose, teaching purpose, as well as the interview preparation. And the resources has the contents available in the format of theories, multiple choice questions, known as pre-test and post-test, and animated web application, popularly known as simulators, and also video materials, as well as reference web links. So to access the labs available here, we have two options: either to go through the logos of your interest, like any IITs, NITK or any private institute. You can just click on the logo and go through the virtual labs developed by each institute, or if you are interested in any of your topics that are covered, are listed here under broad areas of virtual labs. So today's topic is the computer science and engineering, which is the web link over here. You can just click on that link. It will be opening up web page, separate page dedicated for the lab listed only for CSC. So basically here we have list of labs, around 20 labs are developed by the PICs like IIT Hyderabad, IIT Guwahati, IIT Kanpur and IIT Kharagpur. The major contributions to the CSC branch is by the IIT Hyderabad team itself. So we can see more than 10 labs have been developed by them itself. So that are given here. The major topics covered are the recently added are Artificial Intelligence Lab 1 and 2, tagged with the new Artificial Neural Networks, topics on computational linguistics, computer organization, computer programming, cryptography. For the data structures, we have 3 labs: image processing, natural language processing, problem solving. For Python programming, 2 labs, and software engineering and others. So around 20 labs are already deployed, and few more are in the process of development, which will soon be hosted in the portal. So to start with, let me just take the basic lab, which will be common for all the domains in their first year. So that is the computer programming lab developed by IIT Hyderabad. And for the programming itself, we have 3 more. One more is the problem solving, and 2 are for Python programming. Let me just take the first one, the computer programming. Hope my voice is audible. I'll just continue. Yeah, this is the, when I just click on the computer programming link over here in this portal, it will lead to one more page dedicated for that particular lab itself. So this is the page wherein we can see the main sections available over here. As introduction are given, it is to understand the basic concepts of programming, computer programming. So this is the introduction for the lab, and there is objective given, to understand the computer programming concepts. And there is the list of experiments covered. So basically here 9 concepts are covered. The topics like expression evaluation, basic control flow, advanced control flow, functions, pointers, structures, etc. So these are the topics covered under this lab, and there is target audience to whom and all it is applicable, can be useful. So this is the course alignment, and there is a feedback section. So here we can share our experience of the overall lab. If any extra development needs are there, you can just share over here, or any problems with the experiments you can share. Let me just directly go to one of the concept, that is basic control flow. I just click on the link. It is again a separate web page tab. You can see here, this is the aim of this particular experiment or the concept. This is regarding the basic control flow. It explains about the decision-making concepts available in the programming, like the if-else ladder and the switch concept, as it is basic. So these topics are covered, how the decision-making can be done using the program flow as well as the output structures. So this is explained over here. This is just the aim part, and there is theory. How will be the simple instruction flow in the common programming, or if any conditions are need to be implemented, how it can be followed by using the if-else construct, or using the switch construct are explained in the theory part. So well-explained theory is given in the theory section. So before exploring the next topics over here, objective pretest or simulator, you can just go through aim and theory clearly to know about the overall concepts of this particular experiment. Next is the objective, to understand decision making and understand about the control flow. So this is the objective of this particular experiment, and there is pretest. So it is basically the MCQ question to test your understanding. How if you are aware of the topics covered, you can just click on the answers and submit your answers, whether you're correct or not. Just click on submit, and answer will be marked as only. You can see your answers. Some are right and some are wrong. So you can evaluate where it is gone wrong. So this is about the pretest. The same way the post-test is there. Let me just go to procedure. The procedure given over here is the step-by-step instructions that need to be followed in the simulation section. So how exactly we need to follow the simulation section is given in the procedure part. So go through the procedure first before you go to the simulator. Otherwise, you may not be able to complete the simulator part. So these are the instructions. Let me directly move to simulator. So there will be two options. One is with the if-else construct and one more with the switch. So let me just go to the if-else first. So this is the one. Here, this is regarding the if-else construct, if-else and if-else ladder. So here there are three panels. The first panel is for the input and to choose which programming construct you want. The second section is the step execution, where after choosing the type of construct, the program code will be displayed, and as and when we execute, the line of code will be highlighted as the current line of execution, and we can see the code output here in the third panel. So this problem statement is that we have option here to give x and y coordinate of a point over here, and it will be displayed over here, and we have to identify whether that point is inside the rectangle or outside the rectangle. So there will be conditionals applied which will be displayed in the code. So I can just give the value input coordinates, the x value being 50 and y being 100. I have given the input. I have option here to select the if-else code. I'll go with the first one. You can see the code is displayed. Code is displayed, and I can just click on OK. You can see the local variable values are displayed under in the initialized panel itself. Here x being 50 and y being 100, and you can clearly see in the output the point is outside. But in the decision is made in the code where there will be 4 flags being declared and initialized to 0, and each flag will be changed to the value if by considering whether it is greater than x1 or x2, and y being greater than y1 and less than y4. These are the constraints So each flag will be set based on these conditions first. Later, all the values will be checked. If it is true, the point will be inside. If it is false, the point will be outside. As I already told, as I just click on start, the execution will start, and you can see how exactly the code will be executed. You can see under the local variable, each flag getting updated based on the condition. Initialized to 0, the first condition, third condition. Now all flags are set based on the condition extremities, and now all flags are checked for the point being inside or outside. It is clearly that it's outside, and output will be displayed in the output panel. So this is to understand the if-else code construct and the program flow execution. So this is one of the experiments covered under computer programming for the if-else. There is some pretest, sorry. So this is again the MCQ question. You can test your knowledge by just clicking on the options, by clearly going through the code and choose the option and submit the quiz. You'll get the answer. And there are some reference links. So these are the links used by the development team while developing this particular experiment. So to know more about the experiment or the concept, you can just click on the link, go through the web resources and know more about the topic. Next is about the feedback. This is again particularly for the experiment. If any issue or any more development or more upgrades need to be done to the experiment, you can share over here. Yeah, this is regarding the basic control flow. And this is regarding basic control flow. Let me go to one more topic that is covered, the recursion. Yeah. This is the aim part. In the recursion, how big problem can be solved using smaller problems. Using the concept called recursion, this is the aim, and there is objective. And the theory part, theory is given for the factorial of number. So base case, recursive case, how the solution can be found out, well explained in the theory part. And there is a web link given for the concept separately. The theory, you can just go through. There is pretest again. So here, there will be separate sections based on the difficulty levels like beginner questions, intermediate and advanced. So you can just choose the answers and evaluate your answers. So better to go through each of the questions. We may not be knowing all the answers, but this would be helpful if you to know more about the concept. I'll just randomly tick. So we have around 20 MCQ questions, which will help us to understand more. And there is procedure. Again, this is to follow the steps in simulator. So this is the simulation. This is the recent added one. So we have the old link, towers of Hanoi. As we have seen the basic control flow, the panel is same. We have the initialize panel. This is for input. Step execute panel for the code. Code output panel is for tracking our code execution as well as the variables. So I have the option here to enter the number of disks. For this recursion problem, towers of Hanoi concept has been used. So here we have the option to enter a maximum number of 5 to enter the number of disks. I'll be taking 3 for today's demo. Okay. You can see in the code output that disks have been placed in those tower and we have temporary and the destination towers being displayed there. I just need to click on start. This will display the program code, recursion code for getting the output on the towers of Hanoi problem. And we have here, we can't, let me just hide it. Yeah, you can see here, these are the variables that have been used in the code, and it will be getting updated each and every time I just click on next until we get the solution of this problem statement. So I have to just click on next button. You can see the current execution line of code getting executed, and the status of variables being used are getting updated every time I just click on next. How the Hanoi problem statement is solved using the recursion concept is being given here. You can see that is getting placed in respective towers based on the condition and the recursion logic. You can see the status of variables is getting updated. We can keep track how exactly this works. And you can just click on next button and see until we get the solution. Now it comes to the end of the program, and if I just click on next, it will be finished. Now I have got the output based on the recursion problem solution for towers of Hanoi. So this is the simulator for this, and there is separate assignment question, practical assignment questions for the recursion concept. So if anyone interested, try out the logic can be tried out, like how exactly this works. And again, post test MCQ based question based on difficulty level, and there is references. These are again the web links. To know more about the experiment, you can just go through these links. There is feedback again to share our thoughts on this particular experiment. So this is the two experiments which I have covered under computer programming. There are other concepts as well. So exploring the concepts is the same way as I have explained, going through all the sections first, procedure, and then to the simulator. So other concepts are there. If you're interested in your free time, you can just explore. This is about the computer programming. I'll just go to one more lab. That is the data structures 1 by IIIT Hyderabad. Yeah, this is the lab. So this explains about the different algorithm structures that are used in data structures and will be useful in problem solving. So these are covered in this lab, and there is objective given. So it will be having the animations of data structures, and there will be interactivity in the algorithm added. So this is the objective, and the various topics covered under this data structures 1 are based on the topics like sorting, which covers bubble, merge, heap sort, and quick sort. And for the graphs, we have DFS and BFS. For the trees, we have tree traversal and BST. Tags and queues, we have tags queues separately and infix to postfix. We have searching, hash tables are covered, and linked lists are covered. So it's like many concepts are covered in this particular lab. Again, target audience given. Course alignment and feedback and to the entire lab. Under the list of experiments for today's demo, I'll be taking tags and queues concept. Yeah. So estimated time to cover all these concepts given here is for 1 hour, and the objectives are, it is to gain the basic understanding of tags and queues and its operation and complexities and applications of tags and queues. So this is the aim, and there is an overview. This is actually a video. it is to how exactly we can explore this link. Just the video of that. And prerequisites to explore this particular lab or the concept is we must know about the basic knowledge of arrays and linked lists, other complexities, etc. Rest all are covered here, and we have recap of arrays. What are arrays? Array visualization, index part, etc. And time and space complexity. There is a recap of a linked list as well. Before we go to stacks and queues. So what are stacks and queues? Head, data and null, how a node is represented, time and time complexity is given. And there is again pretest based on difficulty level. Yeah, just to check our understanding whether we know about the concept or not. Next is for the stacks and queues, there are separate sections given to understand clearly about each of the concept. So for stacks separate, we have the aim, again, concept of stacks, operations, etc. And there is a concept given wherein a video tutorial is given explaining what are stacks, what are its operation push and pop, and it is presented in pictorial format in the theory part. So in the concept part, you can just go through and you can even go through this video link to know clearly about the concept. And there is a demo part. So here in the demo, it is here the instructions are given how exactly this demo part will work. We have just control over start, reset, and pause, and we can even maximize or minimize the speed. This is the automated one. The question is just that we have some set of random numbers are given in stack A. Using the stack B and stack C, we have to arrange only the prime numbers in stack B and others into stack C. So it will be just click on the start and it will be arranged as per the instructions. Like you can see the top indicators in both the stacks, how the prime numbers are arranged only in stack B and others are in stack C. We can regulate the speed. We have the option here to reset or pause. So this is just a demo actually, and there is arrays practice, like to explain, give introduction to what are arrays. We can make use of this practice section. So here the instructions are given and there are respective buttons and empty array given. We have the option here to enter the data. I'll just enter some value, give the push button. The value will be entered to the array. So you can see the top indicators getting updated as per the operation. And pop will move the last element and clear will clear the array. So this is just the arrays practice, and there is time complexity given for the insertion, deletion, and search operation in a stack based on the best case, worst case, and average case. So that is given, and there is again linked list practice, which will be covered in separate section, and there is quiz. So this is actually a practical question where student can test their logical understanding of the problem statement. Here the instructions are given. There will be two stacks given. One is invisible now, but later while solving the problem, that will be visible. And here there will be two stacks, stack A and stack B. We have the question given here is there are some random numbers are given in stack A. We have to arrange all these numbers in proper ascending order under observation using the control buttons like push and these four buttons, and performing the proper push and pop operations of stack. So I have to use proper these buttons and arrange the numbers under observation using stack B as the temporary one. So these to arrange in ascending. So I have to first find the least number in the stack. So the list will be at the top itself. So I have to use to print to the screen these two buttons to be push and pop between the stacks. I can use these two buttons. So it is at the top itself. the list button, I can just pop from stack and print to the screen 3736. Now I have to again look into the stack, find the next list number, that is 4318, but I have two more numbers which are larger, so I have to push that to one more stack. So I have to pop from A and push to B the 2 times. Now I can see the next list number is at the top of stack A. So I have to just pop from stack A and print to the screen. Next list number would be at the bottom of stack A. So I have to pop other 3 into B, one more stack, 1, 3, pop from stack A. Now it's again from B, 1, 2, 3, from the top of B. I hope the next list number is 8490. So I have to pop from A. I hope I'm arranging in proper ascending order. I hope I have arranged the numbers in proper ascending order by using proper push and pop operation. Now I can just check my answer by clicking on submit. It says correct. So hopefully I have used all the operations in proper ascending order, proper logical way. By this, we can understand how exactly the push and pop operations can be used in a stack to solve a problem like this. So this is suppose the stack. Again, there will be MCQ based questions. After the exercise part, you can just go through. And there is again the same section. Q. There is aim given over here. The concept again explaining. There is a video tutorial actually. So you can go through. It explains what are queues and types of queues. Simple queues, circular queue, its definition and its operation and application. There is demo again. I'll not go to that. And there is time complexity again for NCDQ operations. Queues there is practice, link practice. Quiz exercise. So here again, but for the queues concept, it is the NQ and DQ operation. Again, we have to DQ the elements in ascending order. This is again the ascending order and there are instructions given, but there will be more buttons compared to the last problem. We have to use our logical power and the queues concept clearly to arrange the numbers in ascending order and display under observation. We have one more temporary stack given QB. So DQ and DQB is to display under observation. NQ2B and NQ2B is to between queues. So I have to let me just again check. A set of elements are given in QA. With the help of QB, I have to DQ the elements in ascending order. So I have to display again in ascending order. First, I need to check for the list number. But at the top of QA, we can see it is the largest number. So I have to pop from that and NQ to B, which can be done by the operation button NQ to B. Now I can see as per the queue concept, it is first in, first out. So now it is at the top, front end of the queue. So I just have to click on EQA. Now it got printed under observation. Now I need to check for the next list, but I can see it's at rear end of the QA. So I have to use the button NQ2B. Hope it is right. Now it's at the front end of the queue. So I have to use DQA. Now it's properly there under the QB. I just have to use DQB and again DQB. Now I have arranged proper ascending order. I just need to click on submit. Yeah, it says correct. It need not be the same questions all the time. We have option here to new questions. Yeah, it will be separate question and even there will be sometimes descending order, ascending order. So one can test their understanding about the concept clearly. As many times they want to know more about the concept. So this is how the practice section exercise part in the queue is there. Again, the MCQ based question. And this is the recently added one, the code assessment tool. So here there will be 3 problem statements based for the stacks and queues. And there is again a code panel have been added, wherein we'll be writing the code in JavaScript syntax. And you have the option to check your output. So based on the difficulty levels, there are 3 problem statements are given. So one can attempt in your free time, like write the code and get your output, evaluate your output. This is how it is carried. And there is aim, analysis part. There is aim given. And there is overview. There is overview. This is explaining, this is on the overview of stacks and queues separately in the video itself, and there is comparison of stacks and queues as well. So here, the key differences between stack and queue are explained in pictorial representation. And there is the application of stacks and queues, the expression evaluation, where exactly the stacks can be used and where exactly the queues can be used are given. Again, there is quiz for analysis part separate. So one can use this. And there is post test, again, for the entire experiment. And at the further readings and references material, there are more links. These are the links used by development team. So one can use these links to know more about the experiment. And there is feedback section. There is feedback section where you can share your experience. Excuse me, there is some issue. I'll just join again. Hope my voice is audible now.
Yes, Akshay.
Yeah, sorry. Yeah, this is about stacks and queues under data structures 1. There is one more on linked list. Let me just quickly go through the concept. It is the same way how we had for stacks and queues. There is aim, and it has explained you here about the singly linked list, doubly linked list, and circular linked list. There is again overview. Sorry. There is again overview. It's a video to explore this concept. Again, separate web links are given. There is pretest again. I'll not go through that. And there is concept section. There is overview. Again, a video tutorial explaining what are the needs for linked list, memory management, different types of linked list, its representation. So every linked list is explained in the pictorial representation to know clearly about the concept given here. And there is separate sections covered: singly linked list, doubly linked list, and circular linked list. Each list having sections for its operation, like insertion, deletion, and practical questions are also there. So if anyone interested in any of the topics like singly linked list or anything, you can just go through each of this. How exactly insertion at the front, at the end, and between the node is explained in the pictorial format. It is just the theory part, it is covered here, and the insertion and deletion exactly. And there is practice section. Here, the instructions are given how exactly a linked list can be formed. Here, an empty node, and we have option here to insert at head, insert at tail, and option to search a particular node in the linked list and to insert the data between the node. And we can even remove node from the linked list. So all these are demonstrated in particular animated format. So this will be helpful to understand how exactly the linked list can be implemented at head and null pointers, and the data, how it will be represented. It will be clearly given. So let me just try that. I'll be entering a node. Just insert at the head as it is empty now. Just insert at head. We can see the data and the pointers. Next, one more data I'll be entering. You can see how it is getting added. Add one more. Now I have entered the data to the linked list. You can see the instructions are also given what exactly is happening in the current step. Now, if I want to add at the end, just give it over here, the data value, node value, and give a inserted tail. It will traverse the linked list and add the data wherever we wanted. Now, it will just give whether the value found or not. If I just check for the value, give the value, click on search, it will traverse again. When it is found, it will give the value found. If it is not there, it will give value is not found. If I just give some value again, it will traverse entire, and you can see the value is not found. And if I want to insert any value between the nodes, if I just say 0, 1, at the index value 2, I want to add 88. I just have to give the index value, give the node value, and insert at node. It will traverse, find the index, and add the node at that particular index value. You can see again the linked list arranged as we wanted. And if I want to remove any node value, give the value of the node. Just click on remove. You can see the value will be removed and the linked list again arranged in proper format. So this is actually the practice section. And there is exercise part also again here, and with certain action buttons. This is the one. Yeah, we have the instructions here, how exactly we need to perform this one. We have these many, the series of numbers over here. Actually, we need to arrange this particular linked list in this format. First, we have to check how the node, what are the missing numbers and where we have to add needed numbers in particular index value. So 19, 42, 37 is missing, 64 is missing, 5, 35, 64 and 19 are there. So the missing numbers would be 37 and 64. So it will be actually at insert at node operation, not the head or tail. So I have to just find the index value first and insert that particular number over there. So first is 42 there, 37, 0, 1, 2. So index value will be 2. And enter the number 37. I just click on insert at node. Traverse the linked list. Yeah, now the node gets added. One more, the next number is 64, 0, 1, 2. It will be 3. Index value is 3. And it will be 64. Yeah, insert at node. Now you can see how the linked list is traversed to add the numbers. I hope it is fine now as per the question. I just need to click on submit. Yeah, it says correct. So anytime if you want to change the question, you can just click on reset. So it will be again always a separate set of questions, not the same one, random numbers. So this is for the linked list exercise part. This is just for singly linked list. Same way we have that exercise section under as well as circular. So this is on the linked list, and there is posters, again the MCQ question. Further readings and materials have web links, feedback, you can share your experience. So this is, I have explained action queues and the linked list concept, but we have many options over here, many experiment links for different concepts for under data structures 1 itself. But for data structures 1, we have two more. We have, yeah, two more by IIIT Hyderabad itself. So you can just go through that also. Many other topics are covered here. Exploring the lab is same way. Let me just go to the next one. Let me just go to the next one. That is the cryptography by IIIT Hyderabad. I hope this is the one. Yeah, yeah. This will explain about the fundamentals of cryptographic applications and about the information security protocol. So this is one of the labs explaining that concept, and there is objective given. Yeah, there are topics covered around 10 or different concepts like breaking the shift cipher, another DES, AES, DP-Hillman, etc. These are the topics covered. Let me just take you through two topics over here. The first one, breaking the shift cipher. So this explains about algorithm for key generation gen, encryption ENC, and algorithm for decryption DEC. So yeah, this is the aim part over here. Explains about all these concepts, and there is theory. You can click over here to understand more about the experiment. There is objective. Is to understand that secure encryption is not possible in small case space using this breaking the shift cipher. This is the old one. And these are the procedure steps that we need to follow in the simulator. Not exactly how the breaking the shift cipher can be done. It is in the simulator part how you can use this procedure. And this is the simulator panel. You can see. So part 1 here, this is already the cipher text given. We have to decode that to get the plain text. Here, this is the one. I just need to copy this one, the part 1, and all these instructions are given procedure. So to know more clearly what I am doing, you can just go through the procedure. So here the rough work, if you want to just paste here any data, you can just paste over there. And this is the part 3 where I have to enter the copied cipher text now, and I have option here shift, which is the key value. I have to just check for whether key value is 5, 6 or other given numbers over here. Just give the cipher text over here, take some key value, and perform the. Now I need to get the plain text, so I have to click on decrypt. Now until I get a proper meaningful text, I have to go for choosing other key values and click on decrypt. This is not the one. I just need to take. This is the trial and error method actually. I have to just click on decrypt. I can say this is a meaningful text. Can be the plain text. I can evaluate my answer by checking it in part 4 section of the simulator. It says I have to enter the plain text over here, and I have used the shift key value as 7. So I have to just enter over here 7, and I can just check my answer whether I have generated the proper plain text or not. Just click on check my answer. So it says correct. So my encrypted plain text is correct and the key value is correct. So this is for this is one of the example, and we have many random set of and cipher text available. Using following proper procedure, one can clearly understand how the breaking the shift cipher algorithm works. So there is assignment question as well. You can go through how exactly this works. And the references part, again the link, web link, and feedback. We have the option here to share our experience. So this is one of the experiments. Let me just go to one more, that is Diffie-Hellman key establishment algorithm from this itself. Yeah. So this is again one more key exchange protocol. There is theory given, objective to understand Diffie-Hellman establishment program. So this is the procedure, how the prime numbers and generated G values and other values by Alice and Bob are generated, how exactly it is carried out in simulator is given. So in the simulator, yeah, we have this is just a click of numbers that will explain how exactly Diffie-Hellman key establishment algorithm works. So I have the option here to create a generate a prime number. Just clicking on the generate prime button and can create G value by clicking on another generator button. So I have generated prime number and G value. Now Alice and Bob has to communicate with each other using DS. So Alice has to generate a key value to generate A. Bob has to generate 1, generate B. Now both has to calculate G and GB values respectively. So they have to calculate by clicking on separate respective buttons. Now G by Alice is done and GB by Bob is done. Now both has to share this data between them. No. So Alice will send GA to B and Bob will send GB to A. Now both have received the data. Now they have to calculate GAB and GBA values to establish DS between them so that their communication is secure. Now both have received the same data, means the secure communication has been established between Alice and Bob on DS concept. So this is how DS concept is explained in the simulator, and there is assignment. Again, some set of questions, not the MCQ one. You have to do it manually. So there is the references on the Diffie-Hellman key exchange protocol. So they can just refer this, and feedback again. So if any modifications, any extra improvements need to be done on the experiment, you can just share over here and the team would be doing that. So the other experiments covered are many over here. So anyone interested in any of the topics can just go through in their own time. Exploring the lab is same way I have explained. So this is one of the labs, that is cryptography. Let me just go to one more. That is Python programming. This interface is similar to the one which I have shown in the computer programming lab itself. So it explains about the Python programming construct, and there is introduction given, objective given, and the concepts covered are arithmetic operations, built-in function, loops, strings, and others. And there is target audience and course alignment, and feedback for the overall lab. And under the list of experiments, let me just go to one of them, that is string. So in this, it is to learn the string concept available in Python, and there is theory. So various string methods available, string options available in Python are clearly given in the theory part. So like the concatenation, reversing, slicing, all these things are given here in the theory part. The syntax of the string operations are given, explained, and again pretest. In the procedure, it is the steps to be followed in simulator. So I'll just go to that. So this is the interface. As we can see, it is similar to the one we have explained in computer programming. We have option here of separate string operations like concatenate, slicing, reverse, and repetition. In the demonstration part, we have the option to give, let me just go and give the option for concatenate. So I have the option here to enter 2 strings to concatenate. I'll just enter virtual lab itself. I have optional string also. Just need to click on start button. That will display the code for concatenating the strings in Python. the syntax is given in Python. So I just need to click on next. It will traverse the code, the current line of execution until the execution is complete. You can see the output is given in the ask panel, and this is the code panel. You can reset and try for new set of numbers, new set of strings. Again, I'll go back and just click on one more, the reversing. I'll just give Python itself. Yeah, that, and this is the code in Python to reverse a string, and this the execution flow, and we can see reverse string is displayed in result. I'll just click on reset. Yeah, so almost all the concepts in this Python programming is covered in this way only, like the computer programming format. So to understand basic programming concepts in Python programming. And we have recently added a new one, Advanced Topics on Python Programming Lab by IIIT Hyderabad. One can go through it when one familiar with the topics or to know more about the Python programming topic. We can just go through in your free time. So this is about the Python programming. Let me just go to one more, the Software Engineering Lab. This lab actually recently added. It was there, but it was in Flash. So it was removed. Now they have again added by making the proper modifications in the development, so that it is accessible in web. So these are the topics covered. Many topics are covered, like about 10 of concepts under software engineering. I'll be taking here modeling from problem statements. So this is about how to find entities, its attributes, and how the relationship between the entities can be established in this system is well explained in this particular experiment under software engineering lab. So this is the aim provided, and there is introduction given. So before we go and develop databases for our development thing, we need to understand the relationship between the entities and how exactly the logical model can be formed by using ER diagrams and all. So it's given. This is the introduction, and there is theory. What are the objectives? The objective of this particular experiment is how we can identify entity sets, attributes, and various relationships, represent data model in ER diagram. And there is well explained the theory given right from the entity relationship model, explaining with an example. Students studying in a school, what are the entities and what is the relationship between them? So what are entity set and relationship set? What can be the attributes of an entity? So these are given, and the keys. What are the possible keys in ER model? Entity relationship model, like key, primary key, weak entity. So entity generalization and specialization, mapping cardinalities like one-to-one, one-to-many, etc. And there is again a brief explanation on the ER diagram symbols, graphical notation for ER diagram. So it is given in the pictorial format in the theory. So, and also importance of ER modeling are explained. One can just go through before they explore the simulator. This will give clear idea of what they are going to do in the next part. And there is a case study. So there is a case study given. So this can be used as an example for the students to like exactly how they can crack a problem statement about the entity relationship, model relationship, etc. So it is a very detailed theory with the ER model notations, etc. So this is one of the case study given, and there is pretest again, and there is simulator. So here the simulator is just giving a brief explanation on how exactly we can understand about the entity attributes and the relationship entity relationship model before we exactly go and perform the exercise part. So here one problem statement is given, and we are going to step by step follow how we can go with the ER diagram. So just need to click to play. Yeah, it's given how these are the steps to follow to draw an ER diagram. So identify sets and their attributes first, draw the entities, identify relationships, draw the relationships, and identify mapping cardinalities and represent them. So these are the steps, and they have explained in detail all these steps. So based on the question given here, they are giving all this data. So primary entities in a student, particular school management system is given over here, attributes, etc. Roll number being the primary key. And next entity will be the school. So its attributes and its primary key is given. Next, faculty will be another entity, its attribute. The course, its attributes. Now they are going to represent them in the ER diagram. Each one of the entities they have discovered, roll number being the primary key for the student. Next, this is for the school where ID is the primary key. This is for the faculty where ID is again primary key. This is for the course where ID is again the primary key. So all this data and the ER diagram for each of one of them is drawn. Next. Now they have identified the entity set. Now they will be figuring out the relationships among them. So they have categorized between student and school, faculty and school, faculty and course, and student and course. So all these are the relations they have and clearly given in these steps. Now they will be representing these entities, attributes and relationships identified so far in an ER diagram. So you can just click on next. Having represented the relationship, let's now mapping cardinalities they will do, and this is the relationship model. Next, they will just click on student studies only in one school, but many students can study in given school. So this is the mapping cardinality. Next, faculty works in only one school, but many teachers do work in given school. This is the one relationship. Next, this is the course and faculty. A faculty member can teach multiple courses. However, given course is normally taught by a single teacher. So this is the mapping cardinality. As student can take multiple courses, a single course can be taken by multiple students, so many to many. So these are mapping cardinalities that are discovered. This is how it clearly explains how one can draw ER diagram from, as well as mapping cardinalities from identifying entities, attributes to relationships. It is clearly given in the simulation section actually. So one must go through this part before they go and perform the exercise. So this is the simulator. You have option here again to replay or click to play, or go to a particular step by clicking on these pointers. Yeah, this is regarding the simulator part. And there is procedure. Again, this is to go through the exercise given over here, not for the simulator. In the simulator itself, there is procedure. But this procedure is mainly for the exercise part. So here the instructions are given how exactly we need to perform the exercise part. Let me just directly go to exercise. Yeah, this is the template where we have problem statements like 1 and 2. I'll go to 1. Yeah, this is the problem statement. After all, we have drawn come till the end until we draw the ER diagram. Later, at the end, we can submit our solution to check for its correctness. Do not press now. Just choose the exercise 1, then go down to here. Here, there is one problem statement given. FDP Labs is a company with 2 departments spread across the country, and company has 200 plus employees, and each employee works in a department. So this is the overall problem statement where person has to provide information, details like name, address, phone, mail address, date of birth as its attributes, being employee, the entity, and other entities like department. Other entities like the department. Once all the information are furnished, like identifying unique ID, identifying relationship, and later we will be drawing the ER model. So we have to use the interface features available in the interface. So now we will be just using only the relationship between it will be between employee and the department. It is just between the employee and the department, not to the company. So we are just drawing one relationship. So we have to identify identities. First will be employee itself, one of the identities. I have to enter employee, add, one more will be department, add. Now I have identified two entities for this particular problem statement. All those entities will be populated under the table 2, where we can add attributes for each of the entities. So first will be employee, so which I have added here. It will be populated here, employee. Now I have to add the attributes for this. Here it is given he must have name, address, phone number, mail address, and date of birth. So I just have to add all these attributes. Now I'll be first employee will be having ID. I'll just make it as primary key and just add that. Next, it is given like I need to give the name, employee name, add. Next, employee, let me just give this only. Employee MP mail, add. Employee DOB is added. Employee phone is not added. Yeah. Okay, everything is covered. Address, I think address we are supposed to give. Name, address, mail address. Yeah, I have missed only the address, I think. Yeah, it is the address. So EMP address. Add. I'm done with the attributes for employee. Let me just go with one more department. I'll be just giving the department ID and not this one. Sorry. Here, I'm supposed to add here. First, table 2, I need to finish. It will be department ID first. It will be the primary key, add, and department name, yeah, add. Now we can see the table 4 is populated with proper entities and its attributes. Now, once I have identified the entities and its attributes, I need to define relationship between two entities. So it will be employee between, it is works in department. Employee works in a department, and there can be many employees in a department. Add. So this is the relationship between the entity. Now I have identified the relationship. And you can see all the steps are followed as per the steps mentioned in procedure. Now I have the option here to draw. Yes, I have successfully populated everything, and you can see all my data are fed in the ER diagram exactly how I have given. These are my data itself. So you can see how the data diagram is, ER diagram is drawn. If you're not sure whether your diagram is correct or not, you can just click on submit. It will give its solution, the exact solution, how exactly it is that below our solution. Yeah. This is the exact solution of problem statement. This is how exactly you can use the exercise part covered in this particular problem statement. And most of the concepts covered in software engineering follow this template only. There is simulator part separate and exercise part separate. And there is post-test again to test our understanding about this. And there is references. Again, these are the web links given by the development team to know more about the experiment. And there are contributors like who exactly, and they have given the mail ID to inquire more about their experiment. You can just share over here. There is feedback section where you can share your experience exploring this particular experiment. So they can add or modify their experiment as per your needs. And there are many other concepts covered, like identify the requirements from problem statements. These are newly added, all were there in Flash, and now it's been like converted to web-based. So it is accessible now. So one can make use of this simulators to make the students understand better the concept as it is user-friendly and more of like animation format, pictorial format. So it will be easy to understand for the students. And this is about the software engineering. And in the so we have others also for the computer program, CSC, problem solving. These are the basic ones. If anybody interested in their own topics like artificial intelligence or anything, they can explore the same way. These are the recently added ones. And if at all you are interested in the topics like of other domains, you can just explore the links over here. And many of the topics like for first years and all, there will be common topics like for electronics and all that will be covered in here in other domains like electronics and communication engineering, etc. Like these are the topics that cannot be included in computer science, but it is available in other domains, so that can be useful to explain to the students. These are the simulators. Simulator format will be different, more of type animated circuit diagrams, graphs, and all. It's clearly like presented well, and with a click of button, we can get the graph and how exactly that program experiment will work can be clearly understood. So there are many circuit problems that even this is under the electronics and communication engineering that is covered in virtual labs. So this is all about the links available for CSC. If you are interested in any of the topics in your free time, you can explore and make use of these web resources to know more about the topic or for teaching purpose or learning purpose. Yeah, that's it from my end. If any queries, you can just ask in chat box or ask. With this, I'm going to stop sharing my screen and hand over the session to Shrestha. Thank you. If any queries, you can just ask or put up in chat box.
Ma'am, we have one question from the participant in the chat box. She asked from Mrs. Ramya K. Do we have virtual labs topics related to control systems?
Yeah, good morning, sir. So actually, there are a few new labs added on control engineering. Available under electrical engineering. And also we have few experiments under few of the mechanical engineering labs with concepts of control engineering covered, control systems covered. So you can just explore that one.
Thank you, ma'am, for answering the query. Anybody else, dear participants? If you have any more questions, please put them in the chat box, or you can use your hand raise options. Raise hand option in your Zoom, and then we can unmute you so that you can ask a question. Any more questions? No, I think, ma'am, you have anything else to share? Krishna, ma'am?
Yes, sir. I think there is one more query.
Yes, yes. Can we add lab like Java and SQL? Do you have labs, ma'am?
As of now, sir, Java and SQL have not been added, but they are under development. Soon after the reviews, it can be hosted, sir.
Okay, ma'am. Thank you. Thank you.
Thank you.
Hope that answers the question, ma'am. Anybody else? Anybody have any more questions? But before if any, the others, if we want to ask questions, we have an announcement, important announcement. There's a slight change in the schedule that we are following. Tomorrow, tomorrow is actually scheduled for the core engineering and chemical sciences. But we'll be going with the circuit engineering and physical sciences for tomorrow, because the resource person is available for tomorrow. So the concerned person who will be there, he or she will be taking the session on circuit engineering and physical sciences. So please keep that in mind. Tomorrow we'll have circuit engineering and physical sciences. And following the next day, which is on Thursday, we'll be having core engineering and chemical sciences. So that's the change in the schedule for now.
Yes, sir. So from the domain specific demonstrations, I think we can wind up here, sir. So before concluding, I would like to take few minutes. Is that okay, sir?
Yes, ma'am.
Okay, so let me share my screen. So participants, if you have meanwhile any queries, you can post in the chat box. I'm sharing my screen again. And this is the website, as you all know, website of virtual labs. So here one more thing is, one is Akshaya, when she was demonstrating fifth labs, she, if you remember, she mentioned that older labs were developed using some of the basic plugins, right? So one of the main plugin that which was used was Flash. So flash-based experiments were many. So almost now all the flash-based experiments are being converted to non-flash-based. In case if you come across any of the flash-based experiments, then the consortium has provided with one alternative, which is available in this announcement section. Okay, so there is documentation available, detailed documentation available to use flash-based virtual lab experiments. So you can look into this in case if you come across any of the flash-based experiments across the platform. So basically what they have insisted on us to install VirtualBox. So they have provided a link to download and they have provided step-by-step procedure for VirtualBox installation over here. Then next step is to install customized Ubuntu inside that. So for that as well, link is provided. So customized Ubuntu will allow you to run Flash-based experiments in the browser, default browser available. So with that, you can access flash-based experiments. So kindly go through this documentation to use flash-based experiments if you need. Okay, so that is one thing. And one more thing is, I would like to take you through outreach portal of virtual lab. So we were mentioning about expression of interest form and the nodal centers. So in the website, at the top, you can see outreach portal. Okay, so this provides you detailed information on different nodal centers, different institutes onboarded as nodal centers, state-wise details you will get. Then you will find details on different activities that nodal centers have undertaken. Okay, so number of workshops, usages, and also user trained details will be available over here. So yesterday Marvin sir was discussing on the data of outreach. Okay, so this is the portal. So once you become a nodal center, then your institute name will be available in this outreach portal. So any committee during the evaluation, they will look into this portal to evaluate the activities of any institutes on virtual labs. Okay, and ministry has asked us to maintain this. So whatever activities an institute performs as part of nodal center under virtual labs. So will be required to submit few of the documentations like attendance, a report, and the photographs, which will be updating or uploading to this portal. Okay, so year-wise usage, if you see different participating institutes, the number of nodal centers and the other outreach details will be available over here. And say if I go with one of the state, you will find a list of institutes which are active currently as nodal centers and their activities. So if I take last year data, so these are the institutes. You will be ranked as well based on the usage of each of the institute. Okay, so rank 1 will be institute with highest usage. So this is about outreach portal. Maybe I'll reshare the link of expression of interest form in the chat box. So in case if any of the institute from which faculty members or attendees are from, in case if your institute is not a nodal center for this virtual labs, kindly fill that form. Okay, so I'll post it in the chat box. So do fill the form. Once it is filled and signed, scanned copy can be mailed to our mail ID. Even that I'll put it in the chat box. So just give me a second. So I have posted link of expression of interest form. So this is the form. Okay, so this form will be valid till 31st December of that particular year. So in case if you submit this form in this year, it will be valid till 31st December. And every year in the month of January, you'll be required to renew or resubmit the form. So this is it. And I'll be entering the mail ID as well. Yes, you can mail to solve@nitk.edu.in. Okay, So this would be the first step for any institute to become nodal center or to become part of virtual labs initiatives and proceed further. And one more point to put before you is on RT labs. That was the third type of virtual lab which I mentioned today. Okay, so as part of that, so basically, not all participating institutes, that is 11 participating institutes, doesn't host RT labs. Okay, only few of the institute host. So it is not available in the virtual lab website directly. So RT labs from NITK Surathkal is hosted in a website which is available with the link rtlabs .nitk.ac.in, or in Google, if you just search RT Labs NITK, the first link will take you to this website of RT Labs. Okay, and the experiments are available over here. And also the other things, whatever we spoke at that time, that is Lagupata. The link is available over here. Through this, you can get access to Lagupata videos. So you can just click on them. Okay, different experiment videos are available.
Maybe you can just tell them what Lagupata is all about.
Sir. Hello. Hope my screen is visible.
Yes, ma'am.
Yes, sir. Yeah. So, and this is our YouTube channel, which I was discussing earlier. Center for System Design NITK Surathkal. So, in the playlist, you can get access to different Lagupata videos and details on other projects that we are working here as well. Okay, kindly explore this. And also, we can find virtual tour available over here. That is the different experiments of this particular lab virtual tour is available. You can explore. So basically in detail view of each of the experimental setup, the major things involved with each of the experiment would be provided over here. If you click on any of the camera images, you'll get detailed view of different equipments that are used in each of the experiments. Okay, so this is about virtual tour, Lagupata, and RT labs. So more detailed information would be available in upcoming days sessions. So meanwhile, you can explore this. So I think that's it. So thank you. So participants, if you have any queries, you can unmute the mic or put it in the chat box or raise your hand. So if not, that's it from our end, sir. Thank you.
Yes, ma'am. Thank you very much, ma'am. Dear participants, if you have any questions, you can please post them in the chat box, or you can use the hand raise option so that we can unmute you and you can ask your question. If we do not have any questions, we will close the session for today. I once again thank the NITK team, Shrestha ma'am and Akshaya ma'am for leading us in these sessions. Dear participants, the feedback link will be posted now in the chat box. Kindly fill the feedback link. The feedback is actually considered for your attendance as well. We just posted the link right now.
Yes, and few people have asked in the YouTube if the timings are same. Yes, timings will be same, 10:30 to 12:30 tomorrow as well.
Yes, ma'am. Thank you. Thank you, ma'am. So, dear participants, please note regarding the change in tomorrow's schedule. Tomorrow we will not be having the code engineering branches session as it was mentioned in the schedule, but we will be going ahead with the circuit engineering branches for tomorrow's session. Kindly note that.
Yes, so there will be no EOI registration charges as such. There will be no financial involved in this virtual labs initiative. So it is free. Even the EOI registration is also free.
But once again, thank you all, dear participants, for joining today. We'll see you all tomorrow for next session. Please don't forget to fill the feedback form, which will be considered as your attendance. Once again, thank you, ma'am, Shrestha ma'am, and Akshay ma'am, for the session today.
Thank you, sir.
Thank you, ma'am.
Thank you, sir.
The participants, the form will be closed in 5 minutes. So if you haven't closed, fill the form, kindly fill it. And we'll be closing the session now.